Hi there, my name is Yuan Zhou, and today I will present my fellow project that is about multimodal intelligent album. And in this project, I utilize the capability from large language models and Azure AI Studios to combine them together to produce a very intelligent album that can handle the multimodal input from the users and to retrieve the images intelligently and efficiently. At first, let's quickly go through the questions that we are facing right now. Currently, a lot of the people using their smartphones to take pictures, and there are usually numerous photos in our album. And it is quite hard for us to find a specific photo in it because the photos can be in very massive amount. And to find a relevant photo in it will be a very difficult problem. However, in this project, I'm trying to utilize the cutting-edge LLMs to help the user to find the most relevant photos in their album. The LLMs could help the user to find these photos with much more intelligent capabilities and to save much of the time and energies for the users. Our goal of this project is to enhance the album management efficiency based on the multimodal inputs, such as the voice or ambiguous text descriptions from users. Meanwhile, also provide other features to enhance the user usage and to make it more friendly for the users. Uh, Firstly, we reviewed the related works, such as LLMs. In the LLMs, we utilized the OpenAI GPT-4o APIs that can help the users to help us to understand the user's text input and extract the most useful information by natural language processing capabilities. Meanwhile, we focused on the Azure AI Studios that provides two core functionalities, such as it has the computer vision resources that can help to provide multiple APIs to vectorize the images or text into higher dimensional space and match their similarities using the dot product. So in this way, we can find the similarity between the text descriptions provided by the users and with the image uploaded in our database. Meanwhile, we also utilize the Azure cognitive service from the AI Studio that provided by Azure, which can intelligently process users' voice input using the speech-to-text APIs, so that the voice input can be converted into text and can be easily understood by the LLMs. Let me go through the system architecture of this system. Uh, Essentially speaking, that we combine the two powerful AI tools from the GPT and Azure AI Studio models. As you can see here, that when the users have two options to give their input, the first option is that they just type in their ambiguous text input, and the second option is that they can just speak a word using the voice input. In the first option, that if the user gives the text input, the text will be sent to the OpenAI, and the OpenAI will extract the most useful keyword from the user's input, and based on that, the Azure AI Studio will embed the text into high-dimensional space. And it will also embed all of the images inside the database into a higher dimensional space. And then it will find a cosine similarity between those two embedding vectors. And if they are most similar, they will be presented to the web application that we developed, and that will be presented to the users as their wanted images from the album. On the other road, if the user try to input using their voice, the voice will be sent to Azure cognitive speech-to-text API at first, and that audio will be converted to text, and that text will go through the first pass once again, so that it will be combined together and to allow for multimodal inputs from the users to help the user have a very nice grasp and manage about their albums. For the dataset part, we use the data collection method mainly from the internet that using the advanced crowding techniques. Meanwhile, we also reference the existing large-scale image datasets such as Flickr's 30K and MS Coco. We also enable the keyword selection and data diversity so that our images are both representative and that will basically align with the user search intent, and so that ensure the data set could cover a wide range of the real world scenarios. Meanwhile, we also have done some data cleaning and compliance so that to ensure in our experiment, no data set will suffer the privacy issues or violate the copyright regulations. And then let's dive into the most technical part that we handle the multimodal input using the Azure Cognitive Service. Azure can process user deep voice input using speech-to-text APIs. As you can see in the image, I configured the subscription on the Microsoft Azure platform that I have registered for the speech servers that can dynamically convert the speech into text so that the text can be further processed by the large language models. Then we use the GPT APIs such as GPT-4o to summarize the user's input into a single keyword while preserving its original meaning, so that the keyword will be better understand and have a better performance on the Azure Vector API. That's because in the design of Azure Vectorized APIs, it doesn't have much NLP capabilities. So if we just input an entire sentence, it will be hard for this API to understand. However, if we just provide the single keyword in our experiment, we found that this will lead to a much better performance. To be more effective, the prompt is also strengthened using the channel sort capabilities introduced in the class. So as you can see in this image that this prompt is much more better and it's very effective. That's because we have utilized the channel sort mechanism. Later, for the Azure computer vision resources, we utilize the multimodal embedding APIs that can enable the vectorization of the images and text queries. Firstly, this API will convert images into coordinates inside a multi-dimensional vector space. Then the incoming text queries can also be converted into the vectors. And as you can see here, the A1, B1 is the image vectors, and the A2, B2 is the text vectors. Then it will do a dot product to compute its cosine similarities. And these cosine similarities can be a feature to determine their similarity, how close they are, and what's their relationship. So that in this way, we can find the most relevant images to the input text from the users, and we can lead to the semantic closeness using these cosine similarities and vectorization. After all, we can enhance efficiency by using the preloading strategies. That's because in the Azure embedding API, there's a limit that only a restricted amount of images can be processed in a single request. So to deal with it, we implement these preloading strategies that will pre-process all of the images in our database when the system was first launched, or when the computer has some resources available, so that to ensure that the users can use the system as soon as they want to reduce the waiting time. Our evaluation is also listed here that we have achieved above 90% accuracy, and it has also very strong robustity and reduced response time. And in the future work, we will incorporate more advanced technologies to ensure a higher throughput and to allow more capabilities that can be more customizable. Now let's go through the project that I have established for this final project. As you can see, this is a website that I have established to construct the intelligent multimodal album. Here you can see a lot of the images here. These images are from my database, and it covered a lot of the scenarios, such as amusement park, entertainment, and the restaurant, and office, hospitals, and the shopping, and the libraries. So this place will be found using our multimodal album. As you can see here, I can type in the text about what image I want to find. And I can also record my videos, and the videos will be also inputted to find the images, and that will be transformed into text and to find the most relevant images. Here I will first show the first method about using the text descriptions to find the most relevant image. Here I can type in a place where I can have fun. So as you can see, this is not a single keyword that describes the scenario or the location exactly. As you can see, this is a very ambiguous descriptions, not just an entertainment park or an amusement park. So let me test its capabilities. By clicking this Find Image button, this sentence will be sent to the ChatGPT LLM, and it will help to extract the most relevant keyword about this single sentence. And that keyword will be utilized further in the Azure AI Studio to find the most relevant images by embedding them into high-dimensional vector space. Now I will test another method, that is to interact with the multimodal album using my own voice. Please help me find a place that I can work with. By recording that voice, this text is automatically recognized using the Azure speech-to-text APIs as well. And as you can see, this text is also automatically filled in, and the just said that help me find a place that I can work with. And by clicking this find image, it will also help me find the most relevant keyword. As you can see, the AM successfully extract the keywords at the workspace, and the results are also displayed here. And this shows that all of the images here are all relevant to the office, and this office will be very relevant to what I want to find that I can work with. So this also proved the success and the effectiveness of the system, that I have successfully, intelligently retrieved the most relevant image that I want inside this album.